Hello everyone, welcome to my YouTube channel Shilpa Data Insights.
In this video, we are going to discuss the most widely used keywords in big data. So if you are new to data engineering field, this video is going to help you a lot to get started with the big data. So I will focus on the major keywords and list down all those keywords and explain you each and every keyword in brief. So stay tuned till the end so that you know all the major keywords related to data engineering. Let's first begin with the first keyword of our day, that is node. So in big data world, you would have heard about node. What is exactly a node? Node is a single system in which you will have a storage space, a compute and a memory. So you can think node as of a server in which you will have a compute, a storage and a memory. So let's say a particular system is having a 16 CPU core, 64 GB RAM and 1 terabyte of hard disk. So now, if you know about the big data, it is not only just processing or storing 1 TB of data or 64 GB, right? It is processing a huge amount of data. It could be in petabytes. So a single system cannot go ahead and store all the data and process it all the time. So for that, we have come into another particular concept which is called cluster. So what is a cluster? Cluster is a group of nodes in which you will have different systems. So let's say if you talk about 4-node cluster. So what does a 4-node cluster means? It means there are 4 different systems and all these 4 systems are actually combining all of them creates a cluster. So each particular system will have a particular compute, a storage and a memory. So all these 3 will be present in each of the node, that is each of the single system. So now you think why exactly it's needed like a cluster. The cluster is needed because of the parallelism. Let's say there are 100 petabytes of data that you want to process. A single system cannot go ahead and store 100 petabytes of data, right? So it needs to be distributed across different system, that is different nodes, and it needs to be processed across the system in order to achieve the maximum optimization and maximum efficiency. So that is basically, we will come into our next concept called scalability. What is scalability? It means if you have 4-node cluster, you can go ahead and add another node, that is the 5th node into it, and it will go ahead and store that data and process it. So that is also a flexibility of a cluster, or you can say in the Hadoop environment, you can go ahead and do that. Nowadays, everything is moving into the cloud. So you can go ahead and just add your particular node just by a single or 2 clicks in it, right? So it is such an easy way to do it. Now, a concept of serverless have come up. In that serverless, you don't have to do anything. You just have to mention that this much of data is there and it will go ahead and process that data on the basis of how many nodes are there in the cluster. So let's go ahead and see this by an example. For example, I have 100 students in my class, okay? And I want to calculate the total marks that each student has scored in each subject, right? And I'm giving this task to a single student. So how much time it is going to take by a single student to calculate the total marks? Let's say there are 5 subjects. So how much time it is going to take? So now let's say it is taking around a day, 24 hours to process that. So I decided to give the same activity to 5 students. So now how much time these 5 students is going to take? Will it be faster or will it be taking more time? Definitely it is going to be faster, right? Because I'm distributing the data among 5 students and 5 students are actually processing that particular data, that is calculating the marks of each subject by each student. and then aggregating it, right? So this is going to take less time. So the similar is the concept in our cluster that we have. So the next third keyword is the principle of data locality. This is a very famous and most important keyword in data engineering. So let's say I have 4 nodes, and in that I want to process the data, right? So is it easier to go ahead and move the code, or is it easier to move the data to those particular nodes? It is basically, if data is 4 terabyte, right? You cannot go ahead and move the data every time, but definitely you can move a code to every node, because code could be around 100 KB, right? Not more than that. So basically it is easier to move less data across the node rather than moving a huge amount of data across it. So the next keyword is mapper. So let's say in this particular 4 node cluster, I want to process the data. And if I'm moving the code to the block B1, then it should give me the output, let's say output. So the next keyword is mapper. So let's say we have a 4 node cluster. In this 4 node cluster, I want to process the data, and I will be moving the code into my block 1. So once I have this code, let's say I want to just filter out the data. If I want to filter out the data, it will give me the output as O1. Similarly, I will be moving the code to B2, and it will be giving me the output as O2. Similarly, O3 and O4. So to filter out the data, it doesn't need to go ahead and shuffle the data from B1 to B2 and B2 to B3, right? So it can give me the output independent of each node. So in this case, that is done by mapper. So mapper is specifically used for parallelism, wherever the output is not dependent on each other. In that case, you can go ahead and use the mapper and get the output from it. The next important point that we will focus is on reducer. So basically, what is a reducer? So in some scenarios, you might have seen that you cannot go ahead and get the output similarly as you can do it from mapper. There could be some instances in which you want to move the output from B1, get that output into B2, and then you get the final result, right? In that case, you have another node which is called a reducer. In this reducer, you just go ahead and get the output of O1 and O2, and from there you get your final result as O4, let's say. Okay. Now, when exactly this scenario occurs? This specific scenario occurs when you want to shuffle your data. For example, you want to calculate the average that is there for each marks by each student. To calculate the average, you need to get the output from O1, O2, and then get the final result as O4. In this case, the reducer comes into play, and in this reducer, the shuffling takes place, right? All the output from all the data, all the nodes basically is fetched into the reducer node. So from here, the next keyword that we will focus is on shuffling. What is shuffling? This is a very important term that you might have heard, because in distributed system, there is not one particular system, right? You really need to shuffle the data from one particular node to another. So what does shuffling means? Shuffling means sending the data from one point to another point. So this one point could be one node to your second node. When you are sending the data, then there could be a latency. Why you need to send the data? It could be while calculating some average, or while you are doing some join operation. In these scenarios, you really need to shuffle your data and get the data into a specific node and get the specific output. So in this video, we have seen specific keywords related to big data, which are very useful if you are starting your data engineering keyword. I will come up with some next video in which I will explain you some more keywords in the big data world. If you like this video, then hit the like button, share it with your friends, and subscribe to my channel.
Thank you so much for watching, and I wish you have a good day.